Hello everybody, welcome to today's lecture. So today we're going to go ahead and get started on chapter 9. We did chapter 8 last time, which is about confidence intervals. Um, so that was kind of the start of our statistical inference journey. And I mentioned last time that chapter 9 is probably one of the most important chapters we'll do. Um, and I've been thinking about it. I think it probably is the most important chapter we're going to cover. So I want to really take our time with this one. And I want to go through every section in this. There's 6 sections. So this one's going to take us a few lectures to get through for sure. And then chapter 10 is actually kind of the same thing, except this one is hypothesis testing with 1 sample, and 10 is hypothesis testing with 2 samples. So, we'll see like where we are, but we'll take our time through 9, and then we'll kind of breeze through 10, like just kind of highlighting what the differences are, not really digging into it too much. And then we'll see where we'll go from there. 12 is the other contender for like one of our most important chapters. I think this one's a little more important, but we definitely need to make sure we cover 12 in its entirety as well. So, and like 13 is also another one that is pretty important to talk about. So, all the sections coming up are basically pretty important to talk about. The only one we might not do too much from is chapter 11, but we'll do a little bit from that one. So that's kind of what the game plan is for the rest of the semester. So let's go ahead and dive into chapter 9. So this is the chapter on hypothesis testing. So it's pretty much exactly what it sounds like. It's like, okay, you have a hypothesis. Now we need to test it. So just from that alone, it kind of should demonstrate just how important this chapter is. Because when we're doing research, that's pretty much what research is, right? Like we have an idea, a hypothesis, and we decide, okay, I need to test this hypothesis. So how do we do that statistically? This is where a lot of statistics terms that you might have heard before come into play, like the null hypothesis and the p-value and what it means for something to be statistically significant. A lot of those terms you might have just heard through osmosis come from this idea of hypothesis testing. Okay. So last time we talked about confidence intervals where we're trying to estimate what some kind of population parameter. We specifically were looking at population means in chapter 8, but we could extend it to other parameters as well. So, that's one way that we can estimate the population parameter. But another way we can do it is through hypothesis testing. And, if you go deeper into the mathematics behind it, you kind of can see like there's ways to flip between confidence intervals and hypothesis tests. So they're kind of like two sides of the same coin. So we're going to focus on this side now, the hypothesis test. So the general idea here is we come up with a hypothesis, we set up a test, we use the distribution to do the statistics test, and then we look at the results and make a decision based on that. Okay. So there's a lot of terms we're going to need to introduce. Okay. So first of all, just a little definition here for the hypothesis test. The book doesn't explicitly say this, so I'm kind of paraphrasing here, but a hypothesis test is a process in which a statistician, right, or anybody doing research, doesn't have to be a statistician, but that's just the word the book uses here, is a process in which a statistician makes a decision about certain claims. Okay. So just kind of straightforward, like just exactly what the word sounds like, right? You make a test, you do decision about some hypothesis you had. A hypothesis, if you don't know, is it's kind of like the you come up with a research question, right? And that question that you have is essentially a hypothesis. Okay. So in our case, of course, a hypothesis, um, with our case at least, it should always be something that we can put into math terms. So it should be something like this equals this, or this is greater than this, or something like that. Okay. So those are the kind of hypotheses we're looking, um, the kind of hypotheses we're looking at here. So it involves whoops, collecting and evaluating data from a sample. Okay. Then making a decision as to whether or not there is sufficient evidence to reject the null hypothesis. Okay. Just putting it in quotes here because we didn't define what this is yet, but we will very shortly. But I think this definition kind of encapsulates why this is such an important section. It involves collecting and evaluating data from a sample, then making a decision as to whether there is sufficient evidence to reject the null hypothesis. What this is kind of suggesting is that it's kind of like bringing everything we've done so far together, which it is, right? This is kind of the thing we've been building up to. You can imagine how useful this idea is. Like you can think of like, if you're a jury, then this is kind of the thing you would be doing. You wouldn't be running these mathematical tests to do it. You wouldn't really have that luxury necessarily. But you would be thinking about, okay, is there sufficient evidence to say not guilty or guilty, right? And then like as a lawyer, you'd kind of be doing the same thing. So those are some examples outside of research where it's applicable. But like the collecting and evaluating data, that's what we've been doing this whole semester. So it's coming together into this along with the being able to make a decision about if there's sufficient evidence. Okay. So let's go into the process now. The process of a hypothesis test will look like this. Okay. One, and I'm just getting this again from the introduction to chapter 9, not exactly 9.1 yet. First, we set up two contradictory hypotheses. Okay. That's the plural of hypothesis, which we'll use a lot here because, as this says, we're going to have two hypotheses. So we set up two contradictory hypotheses, and we're essentially just determining which one we're going to choose. Okay. So one will say like, this is true, and the other one will say the opposite is true. Okay. Two, we're going to collect sample data. Okay. Obviously, for our purposes, we're just going to be given the sample data, because we're not actually doing any collecting in this class, at least in the homework problems and stuff. And then we're going to determine the appropriate distribution. Okay. So which distribution do we need to perform the test? We'll talk about that more in 9.3, I believe. Yeah, 9.3. It's typically going to be the normal distribution or the t-distribution. So make sure you're familiar with those from the stuff we did in chapter really 6, 7, and 8. Then we're going to analyze sample data. By performing the appropriate calculations. Okay. Which we'll talk about what those are, of course. And then we're going to make a decision. Make a decision. And we would want to write a meaningful conclusion. Okay. Okay, so this is basically how all scientific research would be done. Okay. When you hear things like, there's no statistically significant difference, that's coming from a hypothesis test. Okay. All right, so let's actually go into 9.1 now. Well, let me recap this real quick now that I have it written here. So we set up two contradictory hypotheses. I'll define those in the 9.1, but we're going to call them the null hypothesis and the alternative hypothesis. We're going to collect sample data, or in the case of like the homework problems, it'll be given to you. We're going to determine the appropriate distribution. We'll typically be using the normal distribution and the t-distribution, but theoretically you could use any distribution. We're going to analyze the sample data by performing the appropriate calculations, and then we're going to make a decision and write a meaningful, I forgot to write conclusion. Conclusion. Okay. Okay. Whoops. Oh, that's okay. Make sure that's okay there. Yep. All right. So 9.1 is called the null and alternative hypotheses. Okay. So let's start there. Okay, so definition. The null hypothesis is the statement that there is no difference between the variables. Okay. This is how the book words it. I think it's maybe a little bit confusing how they word it here. That there's no difference between the variables. What they really mean by that, this is the definition from Wikipedia. is that there is no significant difference between specified populations. Okay. When it says no significant difference, that just means no statistically significant difference. We'll kind of elaborate on that more as we go, but essentially, what statistically significant means is that if we say that there's no statistically significant difference, that means that um, that any observed difference we expect to be due to an error. Okay. So we're basically saying that the probability is extremely low that there is a difference. Okay. So it's all it's in terms of probabilities that we mean this. Okay. Um so this will be one of our hypotheses, one of the two that we have, and we're typically looking at whether we are accepting the null hypothesis, meaning that we're saying that there are no differences between the variables or between the populations, which will be different depending on the context. Hopefully, that'll make more sense when we do an example, which we will in a minute here. And or we're looking to reject the null hypothesis. So this is typically the one we're focused on. We're either rejecting the null hypothesis or sorry, I think I'm saying it wrong. We're either rejecting the null hypothesis or we're not rejecting the null hypothesis. Okay. And not rejecting it is different than accepting it. Okay. Which I'll talk about when we get there. Let me define the alternative hypothesis first. So this is one of the two hypotheses that we'll have. By the way, it is denoted by H sub 0. Okay. So we have H with a subscript of 0. Usually when we denote things with a subscript of 0, we call that null whatever, because null means like 0 or nothing. So we denote it with H sub 0. So the other one is the alternative hypothesis. Is a contradictory statement to the null hypothesis. Okay. So these should be two contradictory hypotheses. It is a claim about the population, just as the null hypothesis would be. And it is what we conclude when we reject H naught, which is the null hypothesis. Okay. So usually the alternative hypothesis is what you are trying to prove, and the null hypothesis is the opposite of that. So that's what the names are trying to suggest. The null hypothesis is usually like the negative of it. The alternative is what you are typically trying to prove. So if you reject the null hypothesis, that means that you are proving or claiming to prove the alternative hypothesis. Okay, so it's a little bit confusing because we kind of put, we're kind of like using double negatives here, right? We're rejecting the null hypothesis, and we're always looking at the null hypothesis and whether we reject it or fail to reject it. We're not usually stating it as accepting the alternative hypothesis. Instead, we would say reject the null hypothesis. Okay. So we typically get evidence, and then we're looking at whether or not we are rejecting the null hypothesis. Okay. And not rejecting it doesn't mean that we accept it. It means, like, for example, if you are saying that you can't, like, if you're on a jury, for example, we have this idea in our justice system, ideally, that you have to prove guilt beyond a reasonable doubt, right? So when you're saying that somebody is not guilty, you're not necessarily saying that they are innocent, right? You're just saying that you don't have the evidence to say that they are guilty. So it's like so like here, we're saying that we reject the null hypothesis, or we fail to reject the null hypothesis. But failing to reject the null hypothesis doesn't necessarily mean that we have the evidence to accept it. In other words, just because we fail to reject the null hypothesis doesn't mean that our alternative hypothesis, which is what we're trying to prove, is false. Okay. It just means that we need to do more, basically, or that we can't claim that yet. It doesn't mean that we disproved it. So after we do that, we make a decision. Okay. Oh, by the way, the alternative hypothesis, that is denoted as H sub A for alternative. Okay. Okay. So once we have evidence, or we have our evidence, we make a decision. So just writing down what I've been saying verbally here, we make a decision, reject H naught, or fail to reject H naught. Okay. I've been saying H naught. I don't know if I specified H sub 0 is right as H naught. As in H naught. Okay, like N-O-U-G-H-T, not, or K-N-O-T, like that kind of not, or I guess just N-O-T because it sounds the same. But it's meant as this word here. Okay. So One thing to note is that HA never has a statement with an equal sign in it. Okay. So, this is very helpful for determining which is the null hypothesis and which is the alternative hypothesis. When we're making the statements, the alternative hypothesis won't have an equal sign in it at all. Okay. So let's finally get to an example so that this can hopefully make a little bit of sense. Let's look at try it 9.1 here. Okay. It says a medical trial is conducted to test whether or not a new medicine reduces cholesterol I spelled that wrong. Cholesterol. Yep. By 25%. So we want to state the null hypothesis, state H naught, and HA. Okay. So let's take a look at how we would do this here. All right. So there's a couple different ways we could think about this. First of all, let's give this variable that we're working with a name. Our variable is reducing cholesterol. Okay. What did I do here with medicine? Forgot the. Sorry, sometimes when I'm just writing fast like this, I make little mistakes like that. Anyway, let's call R the reduce cholesterol. Or maybe I should word this as cholesterol reduction rate. Okay. So how we set this up kind of depends on how strict we want to be. We could say, all right, so one way to do this would be we set up H naught to be R equals 25%, which is what this would be, right? Our null hypothesis would be that the new medicine reduces cholesterol by 25%. So the cholesterol reduction rate is 25%. And the alternative hypothesis would be that R is not equal to 25%. Okay. So this is how we would write it. We would write H naught colon, our variable is this, H A colon, our variable is not this. Okay. Now, I think it's this is kind of a strict interpretation of what the question is saying. I think realistically, if we're looking at whether this medicine reduces cholesterol by 25%, we would be okay if it did 25% or more, right? We don't need it to be exactly 25%. Like if it reduced it by 30%, that would be good too, right? So I think maybe less strict, but more realistic test of what we'd be running is H0 as R is greater than or equal to 25%. So the null hypothesis would be that the reduction rate is greater than or better than 25%. Greater than or equal than 25%. And HA would be that it's less than 25%. Okay. So this is the idea that we have two contradictory statements, right? We have this and this. One of these has to be true, so we just determine which one is true, basically. Okay. Um. Okay. Let's do one more here. Here's one example 9.2. Okay. We want to test whether the mean GPA of American college students is different from 2.0. Okay. It's kind of a weird way of wording it. But it's essentially saying the same thing as we want to test whether the mean GPA of American college students is 2.0. Okay. It's stating this like how we would state the null hypothesis. So our test would be H naught is, by the way, we'll let mu be mean because that's what we normally do. So our H naught would be that mu is 2.0 because it's a statement that the variables aren't different, right? Meaning the mean and the 2.0 are the same thing, meaning they're equal. So again, you got to really like navigate your way through the double negatives here. And the alternative hypothesis would be that it's not 2.0. Okay. So we have two contradictory statements like this. So hopefully this makes a little more sense now. I could sense that it was maybe a little bit confusing back when we were just defining it, because we're not used to writing things like this. So I hope that seeing some examples here clears that up a bit. Okay. There's a whole bunch of examples on in 9.1 if you still want to see more of them. Okay. But they're all very similar to this kind of idea here. Okay. How are we doing on time? Okay. Let's start 9.2. I don't know if we'll finish 9.2. Essentially, when we perform a hypothesis test, okay, there are 4 possible outcomes depending on the actual truth of the null hypothesis H naught and the decision to reject or not. Okay. Sorry, my computer's starting to lag a little bit now. So let's look at a table of what we mean by this. Okay. So we have our action meaning our decision. I think it'd be better just to call that decision. The book calls it action, but I don't know why. Okay, action. H naught is actually and then we'll say the same thing right here. Sorry, my computer is lagging a little bit now, so the words will just kind of appear maybe instead of actually looking like I'm writing them. So we could have H not actually be true or actually be false. Okay, so these are the two possibilities. So we make our decision. So in reality, H naught could be true or false. Our decision could be that we do not reject H naught or we reject H naught. Okay. So what are the possibilities here? Well, if H naught is true and we do not reject it, then that's a good thing, right? This would be correct outcome. Okay. I'll just write correct, but if we make the decision to not reject it and it ends up being true, then that was the correct thing to do. So going back to 9.1, if the mean was actually 2.0 and we did our test and we said we're not going to reject H naught, then we made the right call. And then the flip side to that would be if we do reject H naught and it is false, if it's false, then we should reject it. So that one is also correct. Okay. So again, a good thing. So here, if the mean was actually 3.0, meaning that it's false, and we decided to reject the null hypothesis, then that is a good thing. Okay. So the bad outcomes would be, okay, H naught is true, the null hypothesis is true, but we rejected it. Okay, that's bad, right? If it's true, then we don't want to reject it because that means, we reject a true statement. This is what we call a type 1 error. Okay. Type 1 error. So I'm sure you can guess what this one's called over here. If we don't reject it, but it's false, if it's false, we should reject it. So if we don't, that's what's called a type 2 error. Okay. So there's three possibilities essentially. We do the correct thing, we make a type 1 error, or we make a type 2 error. Okay. Each of these errors are represented by a different letter. Okay. Alpha is used to describe the probability of a type 1 error. Okay. Alpha is the first letter in the Greek alphabet, so it's used for the type 1. That's the connection there. So this is the probability of rejecting the null hypothesis when the null hypothesis is true. Okay. And beta is the probability of a type 2 error. Okay. Beta is the second letter in the Greek alphabet, so it's used for type 2 errors. You might be thinking, we just used alpha in the last section to determine the confidence level. And that is not a coincidence. It's because it's the same thing. But we're not really going to get into that connection. But that's why we're using alpha in both places, is because it is it's representing the same thing. Okay. So in general, of course, we want these to be as small as possible because these are errors, right? We want to minimize our error as best as we can. Um, it's almost certainly not going to be the case that they're going to be zero, right? The probability of making the error being zero, it's going to be almost impossible, right? There's always going to be at least a little bit of a chance that we make an error. Um, the 1 minus beta is known as the power of the test. Okay. So the power of the hypothesis test is known as 1 minus beta, or 1 minus the probability of a type 2 error. So if the probability of a type 2 error is, say, 2%, then the power of the test is known as 98%. It has a power of 98%, we would say. Okay. Um, let's look at an example here. There's a good example not in the book. I'm gonna find it really quick. Okay. So let's think of the null hypothesis as the person is guilty. Okay. So again, we're thinking of like a jury. And the alternative that the person is innocent. Okay. Sorry, I have these backwards. The null hypothesis should be that they're innocent. Okay. And the alternative hypothesis should be that they are guilty. Okay. So I mean, you could use variables if you wanted to. Like you could let P be person and um I be innocent or something, and then you'd have P equals I for the first one, and P does not equal I for the second one. Okay. But we'll just use words here. So let's say that these are our hypotheses. Then what would a type 1 error be? Okay. So a type 1 error, going back to our chart, is that we reject H naught even though it's true. So that means the person is innocent, but we say that they are not. Okay. Is innocent. We say they are not. Right. Okay. So the person's innocent, we say they're not. That's pretty bad, right? Um, we would be falsely convicting an innocent person. A type 2 error, then, this would be that a person is guilty, right? Because it's saying that H naught is false, right? So them being innocent would be false. So it means that they are guilty or not innocent, if you prefer. Person is guilty. We say they are innocent. Okay. So that's also bad, right? We're letting a guilty person go free. Which of these are worse? Well, typically type 1 is considered worse, right? It's considered worse if the person is innocent and we say they're not innocent. Um we still, but in general we want to try to minimize both of these errors, both of the probabilities of these errors. But type 1 is considered to be worse typically. Okay. Um let's look at one more example here. This is try it 9.6. So this one says H naught is that a patient is not sick. Okay. It doesn't actually write it down, but this would mean HA is, you don't even really need HA because it's all relying on H naught, but this would be that a patient is sick. Okay. So it wants to know which type of error has the greater consequence. So first, let's look at the type 1 error. So this would mean that H naught is true, meaning that the patient is not sick. Okay. Is not sick. We say they are, right? The type 2 error here would be that the patient is sick. We say they are not. Okay. So first, we're saying H naught is, so type 1 error is H naught is true, and we reject it, right? Yeah. It's true when we reject it. So in this case, it would be the patient is not sick, but we say that they are sick. Type 2 error is that they are sick, we say they are not sick. Okay. So I think it's pretty clear here that type 2 would be worse, right? Um, if they're not sick and you say that they are, okay, well then, maybe you accidentally treat them. I mean, there's situations where it could be worse, but in general, that's not going to be as consequential as a patient being sick and you say that they're not, because then they'll just keep getting worse. Maybe they'll infect other people, right? There could be a lot more negative consequences to that. So here, the type 2 error is definitely the worst one. Okay. So, yeah. So in this case, the type 2 error is definitely worse. In this case, the type 1 error was worse. I mean, it's a little bit subjective, like which one is really worse. It's hard to really quantify that. But I think in both these cases, those are pretty pretty much the case for those two. Okay, I think that is all we'll do for today. There's lots of more examples of type 1 and type 2 errors here. We're just starting to get set up for hypothesis testing, so next time we will talk about the distributions that we need, and then we can also 9.3 is very short, so we'll do that one next time. 9.4 we'll also do. That's where we're going to start talking about p-values, which are very important, very kind of a hot topic in statistics. And then finally in 9.5, we'll go through an entire hypothesis test, so we'll kind of bring it all together. So yeah, next time we'll definitely do 9.3 and 9.4, and then we'll see where we're at. So thank you for watching today, and I will see you then.